So here we are in problem set 14, looking at problems 11 through 14. The directions say to solve the logarithmic equation, round your results to 3 decimal places. So we do want a calculator handy to do any necessary calculations. So a couple of big ideas. First of all is that A is equal to B if and only if log base C of A is equal to log base C of B. That is to say, if I have an equation, I can take any logarithm of both sides and it'll remain equal. Or if I have an equation with two logarithms, both of which have the same base, then they, in effect, cancel each other out, and I get A is equal to B. Okay. Next big idea is that log A of B is equal to C if and only if A to the C power is equal to B. And this is just the definition of what a logarithm is. Okay, log base A of B is equal to C if and only if A to the C power is equal to B. An example of that would be log base 2 of 8 is 3 because, or if and only if, 2 to the third power is 8. Now, one other option, it really is the same thing, I hope you're going to see in just a second, is that if I have the logarithm, or if I have a logarithmic equation, the verb here is we can exponentiate both sides by anything we want. But what we would prefer is something that'll cancel this log base A out. And so therefore, what I want to do is I want to exponentiate both sides by A. And all that means is we're going to raise both the left hand and the right hand side as powers of A. So what happens here is this A cancels out the log base A, and I'd refer you back to problems 9 and 10 for that. And so what we get here on the left side is B is equal to A to the C power, but that's really what we got up here anyway. So you can either exponentiate both sides of an equation or just rewrite that as an exponential equation. All right, so let's take a look. First of all, log base 2 of 2x minus 1 equals log base 2 of 4x minus 7. Well, taking this first big idea up here, if I have two logs on both sides, or one on each side, I can cancel those out, and I get 2x minus 1 is equal to 4x minus 7. Subtract 2x from both sides, add 7, and we divide and we get x is equal to 3. Taking a look at the next one. Here I have a logarithmic expression, very much like what I have up here. So I have log base 3 of x minus 4 is equal to 2. So we're going to just go ahead and rewrite it as 3 to the second power equals x minus 4. 3 squared is 9. And then we can just add 4 to both sides, and I get 13 is equal to x. On the next one, first of all here, I could go ahead and just rewrite this. This is a log base e. We could do that. But we also have something here. We have a power. And we have a rule that says when I have a log of a power, I can bring that exponent down front. And let's see how that simplifies things a bit. Because now it's 3 times this logarithm. So we can divide both sides by 3. And I get the ln of 3 minus x is equal to 8/3. Now this is a log base e, so if I rewrite this, it would be e to the 8/3 equals 3 minus x. We can subtract 3 from both sides. That leaves me a negative x. And then dividing both sides by -1 is going to make this e negative. It's going to make that 3 positive, so we'll write it as 3 minus e to the 8/3. Now we have to go to our calculator to determine what that is. So we'll go ahead and we'll do that. And I've got 3 minus e to the 8 divided by 3, 8/3. We hit enter. That gives us negative 11.392. And that is the answer to that problem. And finally, we have another one over here. Log base 2 of x minus 4 plus log base 2 of x plus 3 is equal to 3. First of all, we have two logs here, so we are going to have to combine them, condense them, using our properties of logarithms. So this becomes log base 2 of x minus 4 times x plus 3 equals 3. Now I can rewrite this as 2 to the third, which is 8, equals x minus 4 times x plus 3. Now this is a quadratic. We can only solve quadratics that equals 0, so we are going to have to FOIL this out, x squared. That becomes plus 3x. I'll write it. Minus 4x on the inners, minus 12. We combine these two to give us negative x. I'm going to bring over this 8. That makes that a minus 20 equals 0. Now we factor this. I get x minus 5 times x plus 4 is equal to 0, which means x is equal to 5 or negative 4. However, there is something we need to consider here. When we talk about logarithms, again, we just take a look at something as simple as log base 2 of 8 equals 3. Recall, the domain of logarithms is all positive real numbers, meaning I couldn't raise 2 to a power and get negative 2 or negative 1 or negative 8. So whatever we're taking the logarithm of must be positive. So down here, notice if I put 5 into the very beginning, 5 minus 4, I get 1. That's okay. 5 plus 3 is 8. That's okay. But if I plug in negative 4, I get a negative 8 in here, which is not in the domain of that logarithm. So therefore, negative 4 is out, which means x equals 5 is the only solution for that equation. Okay, I hope that helps.